Now we'll see gate questions related to SQL one by one. Okay. The first question: given relations are W comma X, W and X are attributes, and S is a table, Y comma Z attributes. The result of select distinct W X from R comma S is guaranteed to be same as R provided. So stop the video and read the question. So in the question they have given the query select distinct Wx from R comma S. So if you focus on W comma X, you realize that they are the attributes of R. That means you are printing after all R back, correct? All the attributes. Then do you get same as R is the question. So one mistake I can identify is why you don't get R always. Here you are printing distinct Wx combinations. What if your R has duplicates? That is one question. Let me explain you with the example. Example, let's say your table R with this instance. I am talking about a particular instance where Wx contains two values like this 1 comma 2 1 comma 2. Then if you print R, what you will be printed? 1 comma 2 1 comma 2 will be printed. But if you print through this query, what happens we'll see. So select distinct W comma X from R comma S. So we have to take S also, right? So let's take S as Y comma Z, but this YZ values I take only one combination, that is something A comma B, right? Now we know how to evaluate this query from R comma S. That means Cartesian product will be done. If you do Cartesian product, you get 1 to AB 1 to AB, right? So two tuples will be printed. Then distinct Wx combinations. What are the distinct Wx combinations here? 1 to 1 to. Only one combination is there. If I project Wx in the output, 1 2 will be printed. Why only 1 2? Because you said distinct Wx combination. So this 1 2 and this 1 2 are same. So only one time it is printed. But we had two such tuples. Then only one is printed because of distinct. That's why I can say that. So it is guaranteed to be same as R only if R doesn't have duplicates. If R has duplicates, definitely it won't provide the same answer, right? So now let's see the options. R has no duplicates, correct? That is what I realized. R and S have no duplicates. So why S cannot have duplicates? S, we'll see that. So this option says that R and S both should have no duplicates. We will come to this point. So option C, S has no duplicates and R is non-empty. So option C is saying that if R is non-empty, definitely it provides same answer. Absolutely false, because we know that R cannot contain duplicates. Just now we have seen the example. R and S have the same number of tuples. So is it compulsory? Example, let's take only one tuple, distinct tuple 1 2, and here AB comma CD. Then let's violate option D. R and S have different number of tuples, right? Then what will be the output? In the output you get 1 to AB, then again 1 to CD. Then later on you are projecting Wx combination, which is 1 2 and 1 2, right? But you are printing distinct combinations, then only 1 2 will be printed. So initially your table contains only 1 2, now also only 1 2. That means what? For this data, R and S have the same number of tuples? No, but still it provides same as R, correct? This query prints same as R. So, but this option says that R and S should have same number of tuples to produce the same result. Not required, correct? Just now I have shown with the example. So option D is wrong. Now we have only two options, right? One is R has no duplicates and S is non-empty. R and S have no duplicates. Yes, S can have duplicates. I will show that. Example, if I take A comma B again here, so what is the result? You get 1 to AB 1 to AB, correct? Now in R cross S you get this one, and if I project Wx, especially distinct Wx, you get your table R comma your table R back, right? So see 1 2, here also 1 2. That means what? S can have duplicates, not a problem. So but this option says that R and S have no duplicates. Option B is eliminated. So now only one option, R has no duplicates. We know that R should not have. Second one, S is non-empty. Sir, why S should be non-empty? Let's try to understand opposite thing. What if S is empty? If S is empty, so this will be the table, right? Empty table. When you do Cartesian product with the example R and empty set, you always get empty result, because Cartesian product will happen only if at least one tuple you have in the both tables, correct? If S doesn't have any tuple, then R cross S gives empty result here. Then if you project Wx, then you get empty result, but you don't get R back. To get R back, S should have at least one tuple, correct? So that's why I can say that S is non-empty is the perfect answer. So option A, R has no duplicates and S is not empty is the correct answer. Now we will see the second question. In SQL, relations can contain null values. Yes, we know that. And comparisons with null values are treated as unknown. Yes, we know that. Don't skip this statements. Sometimes what happens, they might give some contrast options, otherwise contrast ideas which you learn. So that's why. So you might learn something else, and in the question they might give different things. That's why we have to read the complete information. Suppose all comparisons with null values are treated as true. See, this is one exception. He is specially mentioning that all comparisons with null value should be treated as false. Generally we treat it as unknown, but he is asking us to treat it as false. Suppose all comparisons with null values are treated as, here I wrote true, but it is actually false. Then, so small correction here. Then which of the following pairs is not equivalent? Now let's see the options. So here there are pairs. Which of the following pair is not equivalent? One by one we'll see. See, x equal to 5, not of x equal to 5. So if there is no null value, then both are same, x equal to 5 and not of x equal to 5. So for us, for our simple logic, it is correct. Only we have to check in the presence of null values. Blindly substitute x value null and observe null equal to 5. So whenever there is a comparison between null value and some other value, that is treated as false, correct? So that is what given. So this is false. Now x equal to 5, here again null equal to 5, false. Not of false, true. Not of true, false. So finally this is also giving false. That means what? In the presence of null values, option these two pairs are same. We have to find out which of the following pairs are not equivalent. This is wrong option because they are equivalent. Similarly, we try this one. X equal to 5 is equal to x greater than 4 and x less than 6. In general case, when x is integer, saying x equal to 5 and saying x greater than 4 and less than 6 both are same. But in the presence of null values, what if x is null? So null equal to 5, false. Null greater than 4, I am applying blindly x value null. So this will become null greater than 4 and this will become null less than 6. So null equal to 5 is false. Here null greater than 4, false. Null less than 6, false. False and false, false. So you should understand that why I am taking null greater than 4 as false. In the question they mentioned it. So false and false, false. In the presence of null values also, these pair is having same values. Now see option C. X not equal to 5. When x is null, directly I am checking null. Null not equal to 5, false, correct? Now here null equal to 5, false, but not of false, true. Then I realize that these two statements are not equivalent in the presence of null values. Null not equal to 5, false, but here not of null equal to 5. Null equal to 5 is false, we know that. Not of false is true. So this you got false, this you got true. The both are not equal. So which of the following pairs is not equivalent is option C. Now none of the above is not the correct answer. See this question. So two tables are given. So what you do is stop the video and read the question thoroughly. Try to understand every point, like what is employee ID, what is first name, everything. Okay. Then continue the video. So in employees we have employee ID. We know why we require employee ID, and first name, last name, hire date. Every employee is hired on some particular date, right? So that hire date. Followed by department ID where he is working and salary. Now departments table contains department ID, one unique identification number, maybe like 001. Department has a name, okay. Manager ID, every department has a manager, and location. So locations are like 1700, 1800 in that way, right? So now given this data, what we have to find out is, we have to find out or display the last names and hire dates. We have to find out the employees' last names and their hire dates. What kind of people's hire dates? Of all latest hires. So every department has some latest hire. Example, in department 001, two people are working. So Raju comma Rani, let's say. Raju's hire date is, let's say, 7th August and Rani's hire date is 9th August. Then we have to find out last names and hire dates of all latest hires. Here for this particular department 001, I can say that Rani is the latest hire, correct? So such Person's name should be printed. Rani is the answer, of course. So is the question, but only in the location ID 1700. So if you see in departments, there are a lot of location IDs. So there are some departments which are located at location ID 1700. Only in that location IDs we have to find out the latest hires for only such departments. Example, in 1700 location ID, if there are two departments like 001 and 002, then what you have to do is for 001 we have to find out the latest hire. For department ID 002 we have to find out the latest hire. That is the question. Now we'll see whether this query matches this requirement or not. Let's read the query and execute it. So first understand the query. So if you saw a lot of queries, that means take a query and execute it, you know the way of execution, then you will understand whether this query works for this requirement or not. So let's see this now. What you do is, how you execute the query? Step number 1, step number 2, step number 3, right? We'll try to understand what is happening here. From the employees, you are applying where conditions. Take every employee. So here employee table is given. Now in that department ID hire date combinations, you are seeing department ID and hire date. If it is in this one, so we'll see what is the meaning of this query. So where condition depends on this inner query, right? So what is the output of this inner query? We will see. Since you are using in operator, what is the left side of in operator combination? Department ID hire date. Then right side subquery also produce department IDs and hire dates. Whether it is correct or not, you see. Yes, department ID and hire dates. But what kind of hire dates it is producing? We'll see. Select department ID, max of hire date from employees, join department. Sir, what is the meaning of join? I taught you inner join and outer join, right? So whenever they mention join without specifying the type, whether it is inner or outer, then default is inner. So if really it is outer join, there are three models of outer joins. What are they? Left outer join, right outer join, full outer join. So if they don't mention whether it is left outer join or full outer join or right outer join, we can't say whether it is outer join or not. That's why, so whenever they write join, it is definitely inner join. Only for inner join they write join. If it is outer join, they should mention whether it is left join or right join or full join. That's the reason. So I can say that this join is inner join. Okay. So remember from now onwards that inner keyword and outer keyword are not compulsory, right? But if only simple join, if they mention, it is definitely inner join, not outer join. For outer join, they write left join or right join or full join. Because they did not write anything, so this is definitely inner join. We don't have choice. Now we will see, use this as inner join. That means it's a Cartesian product. So we are joining employees and departments using, now there is a using condition, department ID. So common column is department ID. Using that we compare. Okay. So we equate departments and employees using department ID. Where location ID equal to 1700, remember it. So we take only tuples where location ID 1700, group by department ID. So finally here what is happening is, this entire combinations of employees and departments are taken, and they have grouped by department ID. To understand this query what it is doing, because you are in initial stage, first we take tables, examples, and we do exactly what this query specifies. Let's do one thing. Take this inner query and execute for this data. Let me do it. So there are 7 rows in this employee table and 1, 2, 3, 4 rows in second table, which is nothing but departments. Let's do as specified in the query. What is this query saying? From employees. So step number 1, from employees. Step number 2, where condition. Step number 3, select class. I am just focusing on inner query. So step number 1, employees joined with departments using department ID. Please match department IDs. So result we know that, right? So what is the result of this join? So join gives usually all the columns of first table and second table. Let me mention that. Employee ID, correct, and last name and department ID, then hire date. So since you are equating using department ID and this is using condition, using department ID we are joining them, then department ID will be printed only once, because that will, both department ID columns here and here will have same value, correct? So let me write that in the first column. Usually tradition is people write department ID first, which is common column which we are equating. So let's write department ID, after that employee ID, right? So then last name, then followed by hire date, and department ID already we have written, location ID. So this will happen. Now blindly execute the query, join them using department ID. Department ID is 001 001 matches, right? Then this combination will be taken. What is that? Department ID 001, employee ID 1, last name is, what is last name? A. Hire date of that A is 6th. So I write only 6 comma 8. You should understand that all are 2016. Now location ID. What is the location ID in this combination? In this combination, location ID is 1700. This is one example of tuple because of this join condition. Let me blindly do that join. Okay. Then next, this 001 matches with this 001, right? So department ID should be matched. Then you get 001. So what is that corresponding employee ID? 2. Then last name is B. What is the high date of that? 7 comma 8. Then location is 1700. In the location 1700, there are two departments. So that two departments are mapped to two values, right? So next, see this one, 3 002. This 002 matches with the 002. Then you get 002 on that 002. So employee ID is what? 3. Last name is C. What is the high date? The high date of C is 6 comma 8. Then location ID of that, see here. So here we are talking about department ID 2. Location ID is 1700. Next, we'll go to the next tuple. This 002 also matches with 1002. Then you get here 002, and what is that employee ID? 4, and name is D. What is the hire date? Hire date of that D is 9 comma 8, and location ID of that department 002 is 1700. Right? Then in that way, so this joining will be done. One more tuple will be taken, which is 003. You see 003 003. So that is 003, and what is that ID in 003? 5. Last name of that person is E. Correct. So that person's hire date is 7 comma 8. Then department is 1800. Now one more tuple will be taken, which is 003 department ID. 003 matches with this 003. So corresponding values. Employee ID is what? So employee ID for that is 6. Then last name is F. So hire date of that F is 9 comma 8. So department is 1800. Then this one 005 maps with 005. Last one 7. So this department ID is 005. Name is G, and hire date is 10 comma 8. Then this is 1900. In that way, these all tuples will be joined with this, right? Now see how many tuples we generated. 1 2 3 4 5 6 7. Why 7? Because this 001 matches with this one 1, this 001 matches with this one 2, 3 here, 4 here, then 00303, 6, 003 003, I mean sorry 6. Now 005 005, 7. So that's why 7 tuples are created. Now step number 2, where condition. What is where condition? Location ID equal to 1700. So take only location ID 1700 tuples. So once it is done, I am blindly executing the query. So far joining is done. Now where condition is evaluated. So take only when location ID 1700. Yes, 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 yes. Only 4 tuples will be selected. So since these are all 1800 and 1900s, so automatically they will be rejected, right? Let me erase them. So now easily we can understand that. So if 1700 means only department ID 001 data and 002 data, right? Now, so this 002, there is one more data which is nothing but 001 here with 2 tuples, 002 2 tuples. Then later this, see here where location ID 1700 done, I filtered, but later on we have a step called group by department ID. So of this is, I can say, after 2. So I wrote actually it is 3, but before that group by will be done, right? So this is step number 3. Then final step is this one, select. Step number 4, I can say. So group by department ID. Let's do the group by department ID. Already your data is grouped by department ID. I can say that this is group number 1, this is group number 2. Since there is no having class, directly we will go to select class and print department ID comma max hire date. Here what is happening, you see, so we are combining location IDs which are 1700s and their corresponding departments, and we are mapping that department IDs to the corresponding employee IDs where they are working, correct? So that is what happens. Since you join departments and employees using common department ID, then what you get is definitely this employee ID 1 worked for 001 and that 001 belongs to location ID 1700. So I can say that these are all people are working for departments. So that departments belongs to a location ID 1700. Now in that, if you project department ID comma max hire date, what happens, you see, department ID 001. Now finally it's a time to print the output of this subquery, right? So that is 001 and max hire date on that department is 7,8, right? Now second group. So we know that once group by is done, every group's information will be printed because of the select class. So department ID first 001, next 002. This is the second group. And what is the max hire date? So on that one there is one employee whose hire date is 9,8, correct? So it will be 9,8. Now, so this is the data. How to understand it? So this is nothing but there are two departments who are in 1700 location ID, and in that, so 001 department, the latest hire is at 7,8 and in 002 latest hire is on 9,8. Remember it. Now what we are doing is actual query is this one, right, for us, from where select. Let's execute it blindly. So what this is doing is from employees where department ID and hire date. So whenever your department ID and hire date in this one, you ask yourself why one department ID and hire date, example department ID is 001, hire date is 6/8/2016. Why this combination is not there here? Because these combinations are department IDs and dates which are nothing but maximum hire dates. Since this 6/8/2016 employee his hire date is not max hire date, so he will not be taken, correct? So that is what happening. From employees, take department ID hire date combinations which matches one of them. That's why in operator. So now I can say that, so 001 will be rejected because he is not max hire date. I mean he is not having max hire date. So what about B? In department 2, so what is employee 2 department ID 001 and 7/8/2016 matches. That means this fellow's hire date is max hire date in department 001. So he is the right candidate. For him, what you are doing, because since it is selected, his last name comma hire date you are printing. So what is last name? B. So final output is this one I am writing here. So B is printed along with his hire date. What is the hire date? 7/8/2016. So finally what can you understand about this B? B is working for a department which is located in 1700 ID, and especially that B is an employee whose hire date is maximum. He is the recent or fresher. So second one, what happens after that? This tuple will be processed, right? 3C002 so on. In that, what is department ID? 002. What is the hire date? 6. 002 and 6 is not a combination here because this is only information about latest hire. So that's why this will be rejected. Next 002 to 9 will match this. So 002 and 9th date is here. So that's why this will be taken, right? You understand how in operator works. Then next this one, fifth one. So whenever this is selected, we have to print the output, right? What is that? Last name is D and hire date is 9,8,2016. Now later we will come to 4 and this one 4D, sorry 5. So 5E we will see. So in 5E if you see department ID 003 and hire date is whatever, doesn't matter because we know that there is no department ID in this one. So 003 and 7/8/2016 combination is not in here. That means condition is false. Similarly 00398 is not here. Sir, but 98 is here, right? So whenever you take a combination department ID and hire date, that entire combination should match here. Then only in operator it gives you true answer. So that's why all will be rejected. So just think about the reason why these are all rejected, because they are departments which are not in this 1700 location ID, because we have taken only department IDs which are in 1700 ID because of this subquery. That's why finally I can say that these people. So let's try to understand the output of final query. B and D are the names of the employees who are the definitely latest hires in their corresponding departments, correct? Now we'll see this question. You want to display the last names and hire dates of all latest hires in their respective departments in the location ID 1700. Absolutely, it is working, correct? So yes, for this requirement, this query is correct. Now I did not give you options actually. Sir, what is the question here? There are 4 multiple choices. So one of the choice says that this query, whatever the requirement you have, that requirements out query is this one. So that is the option. So that option is the correct one. Okay. So let me summarize. There are 4 multiple choice question options, and that one option says that for this requirement this is the right query. Second option, one option says that for this requirement this is not the correct query. The reason, we can't apply in operator between this kind of multiple columns. Yes, we can apply in operator for multiple columns also. Okay, not a problem. Then one more option says that this query is wrong. The reason, we can't do group by department ID when there is a join condition. No, it's not like that, correct? For whatever the case, when you have some tuples, we can group them, not a problem. That's why, so it is a correct query, so it works. That's why the correct choice is yes, it works, and for this requirement this is the right query, is the right option. Okay, see this question which is asked in GATE 2004. Employee table is given, name, sex, salary, department name. So consider the following SQL query. Select department name from employee where sex equal to male, group by department name having average salary greater than, select average salary from the employee. So we divide the problem into 2 parts and we execute it. First focus on this nested part. So subquery. So here what is happening, in employee table we are just calculating the average salary, right? So I can say that this is average salary of the total employees, remember it. Example, the value is 5000. So this 5000 represents average salary of the company. Now go to the outer query. So step number 1 is what here, from employee table take where sex equal to male, that means only take male employees. Now we are going to print output from outer query and we are going to print the department names. Okay, so where employees are male, group by department name, that means that male employees, so far employees are taken, sex equal to male are taken, that means only male employees. So their department names, that means we are grouping by department name. All such employees are grouped by department name. So we can imagine your data like this. So department A, all the people of department A, maybe employee 1, employee 2, employee 3. Department B, so employee 2, employee 4, employee 5, employee 6, in that way. But remember, these are all male employees. Then later after group by, having condition is executed. So what is having condition? This having condition is whenever a group has average salary greater than this one. What is this one? Average salary of the company. So any group has average salary greater than the total average salary of the company, such department names are printed, right? So directly now the printing step, this is the final step, right? 1, 2, this is group by step number 3, having step number 4, then step number 5 is printing the department names. Now read the question. It returns the names of the departments, yes, but what kind of departments? Only having average salary. That, see here only average salary of the male employees in the department. Why? Because already we are taking only male employees, correct? I can say that we are printing the department names whose male employees average salary greater than average salary of the company. Now if you see the options, option A, it returns the names of the departments where the average salary is more than. It's not about average salary of the department, it's average salary of male employees. See, because the sex equal to male. So go to option B. The average salary of male employees, correct, is more than the average salary of the male employees in the company. Right side we don't have male employees, we have all the average salary of the company, right? So that's why option B is wrong, because it is saying that average salary of male employees is more than the average salary of male employees in the company. No. Now option C, the average salary of male employees is more than the average salary of employees in the same department. So it's not about same department. You see the mistake in option C. It says that average salary of male employees, correct? It's here. We are taking every time average salary of male employees of the department. But here you see, is more than the average salary of employees in same department. It is not average salary of employees in the same department. It's average salary of total company. So that's why option C is wrong. Now see the last one. The average salary of male employees in the department is more than average salary in the company. Perfectly right. So that's why option D is the right choice. Okay. See this question which is asked in GATE 2005. The relation book has title and price. Title is a unique attribute which uniquely identifies the book, and price contains the titles and prices of different books. Assuming that no two books have the same price, that means no two books are having the same price. Every book has a different price, remember it. Then what is the output of the following SQL query? So one SQL query is given. We have to see the output of it. We know how this query will be executed. Step number 1, step number 2, step number 3. Let's try to execute. So we have a book as B. That means we have an instance of book that is B. Okay, let's say this is B. So I have taken some sufficient tuples like 1, 2, 3, 4, 5, 6. 6 tuples, and there are 6 books and their prices are 500 range to 1000. Now take the first tuple. We know that first tuple will be evaluated using where condition, after that second tuple, so on. In the first tuple, so the question is whether this tuple is printed or not. What is the corresponding attribute? Title. So A is printed or not is the question. It depends on the where condition. But in the where condition you wrote a nested query, right? So this nested query to be evaluated. So I can say this one is correlated nested query. The reason we are using outer queries variable B here. What is B dot price? 500. After fixing 500 here, we have to run this query. Let's try to understand this query. Select count star from book as T. So there is another instance of book that is T. Okay, on that T this query is evaluated. So take every tuple from T. Whenever T dot price greater than 500, then such tuples should be counted. That is the meaning of this query. So count the tuples from book T where T dot price greater than 500. So 600 greater than 500, 700, 800, 900, 1000. So all these tuples will be selected because of this query execution. Then what is the count of such tuples? 1, 2, 3, 4, 5. Finally this query's output is a single tuple, that is 5, right, because of aggregate operator. Now the question, is this 5 less than 5? No. Then condition is false. Then I am sorry Mr. Book A, you are rejected. Then go to the next tuple, that is B and 600. This time we keep price of that second book which is 600. Now this query will be executed. So this query is again same thing. Iterate over all the books T where T dot price greater than 600. Such tuples to be counted. So 600, 500 greater than 600 false, 600 greater than 600 false, then 700, 800, 900, 1000. These 4 tuples will qualify this condition. Such tuples count will be 4. Since 4 less than 5, we print it. Now I would like to ask one question here. Finally, what's the meaning of it? We are fixing one book here, which is outer queries tuple, which is to be printed, right? That tuple's title should be printed. Before that, we are keeping the price of that book and we are running this query. So here 4 tuples, that means 4 books, their prices are greater than 600. That's why 600 is printed. That means the title of that. What does it mean? There are only 4 books whose prices are greater than this 600 price, right? So try to understand that. Now later we fix this to 700. When you fix 700, then there are only these books 800, 900 and 1000. Their prices are greater than 700. So their count will be 3. Since 3 less than 5, again such books title will be printed. Now try to understand what are the things will be printed. So I can say that this book will be printed, this book will be printed, this one will be printed in that way. So 1, 2, 3, 4, 5. 5 books will be printed, correct? So why exactly 5 books printed, I will tell you. When you keep a book whose price is, fifth most expensive, that means there are only 4 books whose ratings are, whose prices are more than a particular book. Example, What is the problem with 500? I will tell you. So when you substitute 500, there are at least, you see, 1, 2, 3, 4, 5. There are 5 books whose price greater than 500, then the count will become 5. If you have more books like, so 1100 book, 1200 price book, in that way, then that count will be increased by, more, then this count star will be greater than 5. I want to have a count star which is less than 5. Tell me what are the possibilities you have to have less than 5? 0, 1, 2. Count star can have 0 value, 1 value, 2 value, 3 value, 4 value. Right? Ask yourself, when you get count star 4, if there are only 4 books whose prices are greater than your book price, that means what? Yours fifth most expensive book. Whenever a book is fifth most expensive, then there will be only 4 other books whose price is greater than this book. So only 4 times this condition will be satisfied. Then this entire query's result will become 4. Now, if your book is fourth most expensive, then there are only 3 books whose prices are greater than B dot price, then only 3 times this condition will be satisfied. Then count is 3, correct? Since 3 is less than 5 is true, this book also will be printed. Now I can understand that fifth most expensive will be printed, fourth most expensive will be printed, third, second, first. Sir, why first most expensive book will be printed? When you substitute first most expensive, that means highest book price, then every time this where condition will be false, correct? So count will become 0. Understand? So now I will tell you. So count is 0, count is 1, count is 2, count is 3, count is 4. In these possibilities only, query will become true. That means this where condition will become true. For that, to have count 0, the book should be most expensive. You are getting count 1 means that bid price. So that's price. I mean, other books are, I mean, there is only one extra book whose price is greater than this price. So in that way, I can understand that only 5 most expensive books will be printed. So answer is, so this query prints 5 most expensive books. We'll see this question, GATE 2005 question. The relation book has title and price. Title is primary key. That means every book has a different title. Assuming that no 2 books have the same price. So it is given that every book has a different price like this, 100, 200, 300, in that way. So in this scenario, what is the output of this following query? Select title from book as B, where select count star from book as T, where T dot price greater than B dot price less than 5. So we know how we execute the query, right? Step number 1, step number 2, step number 3. To evaluate step number 2, there is a nested query we have to evaluate. How to evaluate nested query? Whenever you want to execute step number 1 here, step number 2, step number 3, correct? So there is a book instance B, another one is T. So in nested query we are using T instance. So let's begin blindly from step number 1. From books B, so this is books B, first of all we take the first tuple, correct? Then after that we substitute that B dot price here, which is 100, and we run this query. So when you run this query, so here book as T, that means tuples of this T will be evaluated, right? Everything. Take every tuple and evaluate this query. So take the first tuple. So when you substitute T dot price, that will become 100, 100 greater than 100 false, correct? So this tuple will be rejected. Now you tell me, so how many tuples satisfy this condition? 200, 300, 400, all these tuples will satisfy this condition. 7 tuples are there. 7 times this condition will become true, then count star will become 7. 7 less than 5 is false, then this tuple will be rejected. Now ask yourself, why this first tuple is rejected? The reason, there are 7 other books whose prices are greater than your book's price. That's why your book is not printed. To get printed, so the count here, you see, this count should be less than 5. What are the possibilities to have count less than 5? What is this count star gives? This count star gives 0, 1, 2, 3, 4 and 5, 6, 7. All these things definitely will make this condition false. To have condition true, only these are the possibilities. Ask yourself, when count star will become 0, then this where condition should be always false. If this where condition is always false, then every book price should be greater than the substituted book price. Every book's price, whatever you substitute, that should not be greater than your book's price. That means your book should be a book with highest price. Example, your book price is 800. Then all other tuples, if you substitute, every time condition will become false, count will become 0. Then what is the property of your book? Highest book. So finally, first highest will be printed because of 0. Only first highest gives count 0. Now ask yourself, which book will give count star 1? For that, this where condition should be evaluated only exactly one time to true. For that, there should be only one book whose price is greater than your book. For that, your book should be second expensive. Example, your book is second expensive in this problem 700. Then if you iterate over all the books, then only 800 will satisfy this condition. Then count star will become 1. Then 700 is the book with second highest price, correct? So I understand that. So first highest book will give count 0, second highest will give 1, third highest will give 2, fourth highest, if you substitute, it gives count star 3, and fifth highest book with respect to expense will give count 4, right? So finally 5 most expensive books will give 0, 1, 2, 3, 4 values. So only such books will be printed. So the output of this query is it prints 5 most expensive books titles. Let's solve this problem. Employee table is given with employee ID and name and department salary. So easy to understand. Department 5 has more than one employee. Okay, fine. So I think we are going to use department 5 in the queries. That's why they gave. Now we want to find the employees who get higher salary than anyone in the department 5. Try to understand the requirement clearly. We want to find out the employees who get higher salary than anyone in the department 5. That means this anyone means everyone in the department 5. That you should understand. So whenever any and one combinedly written without space, that means it is everyone. Example, I give some similar statements. My salary, let's say, greater than anyone in this world. If someone says that, what does it mean? So his salary is greater than everyone in the world. Second one, so one wrestler, otherwise one bodybuilder is saying this one, I am stronger than anyone in the world. That means what? He is stronger than everyone in the world. In the same way, here we want to find out the employees who get higher salary than anyone in the department 5. That means everyone in the department 5. If you understand that, you can understand these two queries. Now the question, out of these two queries, which one is giving this output? That means equal output to this requirement. We'll see now. Select E.employee ID. I'm focusing on query number 1. From employee, we know the steps, right? Step number 1, step number 2, step number 3. In the step number 1, take employees where not exists of this one. I think it is correlated nested query. Correct. So here E.salary is fixed. So what we do is we are going to execute this query for every employee E, right? Let's focus on only one tuple. Okay. So in employee, the first tuple is, let's say, Raju. His ID is 1. His salary is, let's say, 5,000. Okay. Now, whenever we execute this query on behalf of the first employee, then E.salary will become 5,000. Right? Let's begin this execution of nested query. Now try to understand, because our main query depends on this nested query. Select star from employees S. That means one more table is taken, which is nothing but again employees, but the name is S. Take every tuple from employee S where S dot department equal to 5 and S dot salary greater than or equal to 5,000. What is the output of this query? It is a collection of employees where department is 5 and salary, that employee salary greater than or equal to 5,000. What is 5,000? This 5,000 is nothing but a person who is going to be printed here, correct? Really, if this person you want to get printed here, then definitely his salary, see here, once you substitute, this should satisfy this where condition. We know the not exist logic. Not exist of dash is true, not exist of empty is true, correct? For that I want empty here. That means always this where condition should be false. So I can say that this query's output is nothing but it's because of this where condition. If this where condition is always false, so you get empty table, right? To get empty table, S dot department 5 and S dot salary greater than or equal to 5,000 should not be true at a time. So to understand it clearly, what I do is always I go for opposite thing. When this condition will be false, you tell me. At least one time this where condition is, let's say, true, what happens we'll see. Example, at least one time this where condition is true, at that time there will be S dot department 5, there will be one department 5 employee whose salary, S dot salary, greater than or equal to 5,000. Example 6,000. Really there is an employee in department 5 whose salary greater than or equal to 5,000, like 6,000. This query will give non-empty result. Not exists of not empty is false. Then our corresponding this 5,000 salary employee who is 1, that ID will not be printed. This is the story. Now the question, when this will not be printed, what is the reason this is not printed? Because in the department 5, someone's salary greater than or equal to 5,000. If there is no such person in department 5, if there is no such person, then this condition cannot be true at any time. So where condition will be always false and you get empty result here, then not exist of empty is true, then our person which we are talking about will be printed. Now tell me when a person will be printed, whose his salary when you substituted here, that should be always greater than everyone in the department 5, correct? So this is perfectly our question. You see, our requirement is we want to find out the employees who get higher salary than anyone in the department 5. So this tuple, when you are printing his salary, when you substituted, it is this result is empty. To get emptiness, definitely where condition should be always false. For that, in S dot department 5 and S dot salary greater than or equal to 5,000, such tuple should not exist. That means no one in the department 5 should have more salary than this to be printed person salary. That means what? Definitely the to be printed person salary greater than 5,000. I mean greater than everyone in the department 5. Perfect. So this is the requirement which query 1 is satisfying the requirement. Now see the query number 2. Select employee ID from employees where E dot salary, we are printing the employee IDs of the employees whose salary greater than any means at least dash, we'll see here. These are all distinct salaries from employees where department 5, S dot department equal to 5. We can say that this query's output, subquery's output is all the salaries which are of course distinct from department 5. These are all department 5 salaries. Now your employee ID, to be printed employee ID, if his salary greater than at least one person in the department 5, automatically this where condition will be true and we are printing it. You tell me now when this E dot employee ID will be printed. His corresponding salary greater than at least one person in the department 5. But that is not our requirement, right? It is everyone. I want everyone salary should be less than our to be printed person salary, correct, in department 5. So that's why query 2 is absolutely wrong. So that is a trick here. In GATE exam, they are just checking whether you understand the query or directly you match strings like this, any and any, both are same. Some students do that. That's why they give this kind of questions. They don't understand the meaning. Any and any, both are matching. Then they go for query number 2 and they say query 2 is the correct answer. Absolutely wrong, correct? So finally what I want to say is the output of this query, otherwise the requirement of ours is satisfied by query number 1. Only query 1 is the right choice. Now we'll see a query which is asked in GATE 2006. So account table is given with two attributes, customer and balance, where customer is the primary key that is mentioned. Now no null values are there. So we should not worry about null values. We would like to rank customers according to decreasing balance, that is a target. So he is explaining the requirement of what we have to do. The customer with largest balance gets rank 1, okay. Ties are not broke but ranks are skipped. That means, example, see this data. There are 3 customers, 1, 2, 3. Let's say these are all customer IDs and balances are 100 rupees and 100 rupees and 200 rupees. Then what happens is, so highest balance is customer 3, right? He gets rank 1. Now second balance, if you see 100, right? Second highest, but there are 2 people. So for both of them we have to give rank to rank 2. So that is what he is telling. Ties are not broke but ranks are skipped. That means next time if you have another customer with balance 50 rupees, then he will be given 4th rank. That means ranks are skipped, okay, but ties are not broke. So if 2 people are having same values, they will be getting the same rank. That is what he explained finally. So this is what your requirement. Then this query is that satisfying the requirement or is the question. There are two queries. This is query 1. First I explain query number 1 whether it is correct or not. After that we'll see query number 2. After that we'll see the multiple choices. Let's see query number 1. What is our requirement? We should get this kind of ranks, right? Let's read the query and we understand it for some data. Select A dot customer and count of B dot customer from account A, account B. That means same account is taken 2 times. Then comma means Cartesian product is done. Then where condition followed by group by. Let's take the data and execute it. Let's take a, whenever they give this kind of questions, take some data and understand the query. So there are two advantages of taking the data. If you take some small data, you understand the requirement. I mean, you understand how query is evaluated with the example. Later we can have, we can justify, otherwise, we can summarize the things. So let's take customer now. So customer and balance, right? So let's take, because balance can be repeated, remember it. So customer and balance. Let's take customer 1, customer 2, only 2 people. Balances are, let's say, different values, 100 and 200. For this data we will see first. So there are two account tables, right? Account A, account B. That's why let me take 2 times. So account A, account B. So 100 again, 200. Let's call it as A. Let's call this as B. Then let's blindly execute this query and we'll see whether our requirement is satisfied by this query or not. Step number 1 from class, just done, right? Account A, account B, Cartesian product. If you do Cartesian product patiently, you get this kind of structure. What is that? 4 columns: customer, balance, right? Again customer, balance. So this customer balance from here and this customer balance here. So data will be, since Cartesian product, right? We have to get 4 tuples. What are they? 100, 100. Then 100 is attached with 200. Then 200 is attached with 100. Then 200 is attached with 200. So this is so far done. Step number 1. Now step number 2. Where A dot balance less than or equal to B dot balance. We know that this is A, this part is B, right? So let's execute blindly. A dot balance less than or equal to B dot balance. A dot balance less than or equal to B dot balance. This tuple is selected. Now 100 less than or equal to 200 selected. 200 less than or equal to 100 rejected. 200 less than or equal to 100 selected. So finally only this tuple will be rejected from the result. After that group by should be done. Step number 3. We know that step number 1, step number 2, step number 3, step number 4. In step number 3, group by A dot customer. Focus on A dot customer. See. So this is group number 1, right? So this is group number 2. Now once grouping is done, then what to do? Print whatever mentioned in the select class. Prints A dot customer for every group. So what is the A dot customer for first group? 1. I am printing the output A dot customer and corresponding count. Since group by is done, this count is for a particular group. So for this particular group, what is the count? Count of B dot customer. So B dot customer is this one, right? Sir, I think it is 1, 2, 3, sir. Don't go to the second group because we have to print count for every group separately. So count will be 2. Then next time, second group customer, A dot customer in the second group is 2 and count of that B dot customer is only 1, right? Because one tuple from that group is rejected. So now you get this output. So 1 got rank 2, 2 got rank 1. 1 got rank 2, 2 got rank 1. Yes, it's working. But don't say that it works always. By just taking one example, we should not say that this query works for everything. So what we do is, we take now this time, because this entire concept is about, duplicates, right? Because we have sometimes ties. So ties should not be broke, but rank should be skipped. So all these things also should be satisfied by your query. For that, let me take data with duplicates. Then only you understand whether this query is giving correct answer or not. Now we have duplicate data. That means balance is repeated. Then whether it works or not, we will see. When you have this kind of duplicate data, if I execute the query, first what we have to do? Account A, account B. Yeah, this is account A, this is account B. Then Cartesian product. When you do Cartesian product, what you get? You get like this: 100, 100, then 100 versus 200, then 200 versus 100, 200 versus 200, right? So this is 100. So far Cartesian product is done. Once Cartesian product step is done, then step number 2, where class A dot balance less than or equal to B dot balance. Since all the balances are same, always this condition will be satisfied. See, this is A, this is B, this is balance, this is balance. So always A dot balance less than or equal to B dot balance. Correct, correct, correct. Everywhere it is correct. So what to do then? Group by. Group by A dot customer. So here what is customer here? This one, right? Group by A dot customer. Then this is group number 1. This is group number 2. Correct? Every distinct customer is a group. Now in G1, what we have to do? Go to step number 4. Select A dot customer. Yes, first time it is 1. Then print count of B dot customer. This is count of B dot customer, right? Which is 2. Then take the second group and print A dot customer, which is 2, and count of B dot customer is 2. Then you get one's rank as 2, second rank as 2. But is it correct? Actually both should get same rank, which is nothing but 1. But you got 2 and 2. That means for some kind of data, especially duplicate data, this query is not working. Remember it. Now we'll see query number 2. See this query 2. Select A dot customer 1 plus count of B dot customer from account A, account B, where A dot balance less than B dot balance, group by A dot customer. So this query is little bit modified. I can say that this is modified version of query number 1. So query 1 was not working, right? We'll see whether query 2 works or not. So what we do is we directly go to duplicate data, because with duplicate data we got the problem, right? So we assume that this query also gets problem with duplicate data. Let's try. For that I take this data, because we have to take account 2 times, right? Let's say this is account A, this is account B. Now data is like this: 100 and 200, again 100, 200. Let's see duplicate data. Start. First step number 1, account A, account B. That means Cartesian product. If I do Cartesian product, you get this kind of data. What is that? 100, 100, then 100 versus 200, then 200 versus 200, then 200 versus here it is 100, 200. So 1 with 1 2, 2 with 1 2. Yes, done. So this is A, this is B part, right? A part and B part. Then where A dot balance less than B dot balance. If you see the data, all are same values, right? Then A dot balance less than B dot balance is always false. So rejected, 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 rejected. No tuple will be selected because of where condition. Later, so if I reject this entire data, you get nothing. So you get empty table. So far we have empty table after where condition. Now step number 1, step number 2, step number 3. We are at step number 3. Group by A dot customer. What is there to group? Nothing is there, right? Then you simply say that yes, group by is done. Empty table is grouped into 0 parts. Then select A dot customer. So nothing. 1 plus count of B dot customer. So what is count of B dot customer? There is no A dot customer. For every group we should do these things. First of all, try to understand. Sir, what if we don't have groups? Don't do anything. Correct? So finally empty table will be printed. If you have any group like this, at least one group, then that customer name and count of 1 plus count of B dot customer we print. When you have already empty table, so no groups, nothing to print. So output is empty, but that is not our requirement. Our output supposed to be, so customer 1, his rank is 1. Customer 2, his rank also 1. This is what my data, correct output. So this query is not giving the correct output, right? So you remember it. Now we'll see the options and statements, like which one is correct, which one is wrong. They have given 4 choices A, B, C, D. We have to identify the right one. Before that they have given 5 statements. We'll read them. Query 1 will produce same row set as query 2 for some but not all databases. Actually it is correct. Sir, how can you say that query 1 will produce same row set as query 2? Did you check it out? No. What we do is we directly take empty tables, because we can take any database. The question, if you read this statement, if you read clearly, query 1 will produce same row set as query 2 for some but not all databases. Yes, I show some database. Example, take empty table, right? Take empty table in both places. So if I take empty tables, what happens is, that means if I apply all this query, you get empty result. For previous query also, if you take empty table, output will be empty. Remember it. For empty table, query 1 gives empty result, query 2 gives empty result. Now read it. Query 1 will produce same row set as query 2 for some but not all databases. Correct. For empty database, both queries will work same, right? Now second one, both query 1 and query 2 are correct implementations. Absolutely false. None of them is correct implementation. We have seen it, correct? Now query 1 is correct but query 2 is not. This is wrong. Query 1 also not correct. Now neither query 1 nor query 2 is correct. Yes, absolutely right. Now assigning rank with pure relational query takes less time than scanning in decreasing balance order, assigning ranks using ODBC. You don't know what is ODBC, JDBC, right? Don't worry. So it's not about, this. If you don't know 5 also, you can answer it. Sometimes they give this kind of weird statements. Don't worry about them, because so no one can cover all the databases. Okay, so this is about ODBC, but we don't study ODBC for GATE, because very rarely they use this kind of ODBC word, JDBC. For that we can't read entire chapter, right? And that is not mentioned in the syllabus also. That's why. But don't worry. Sir, can we answer this question or not? Yes, we can answer, because we have to identify the right option. Go to the options, you understand how easy this question is. 2 and 5. So you don't know about 5, correct? But you know about 2. 2 is absolutely wrong, correct? That's why this is wrong. Now 3 and 5, option D. See why I am going to directly option D is, so you are worried about 5, right? So what is 3 and 5? 3 is already wrong option. Then irrespective of 5, this is wrong choice. That's why even you don't know ODBC concept, we can answer this question. Now 1 and 3, 1 and 4. 1 and 3, 1 and 4. So 1 and 4 are the correct choice, right? So option C is the right choice.